Welcome. In this video, we are diving into Thomas Kuhn's revolutionary work, The Structure of Scientific Revolutions, a book that forever changed how we think about the nature of science. Kuhn's idea of paradigm shifts, the cyclic process of scientific progress, and how scientific revolutions transform our understanding of the world have become essential readings in the philosophy of science. So, if you're ready to explore how science really evolves, let's jump in. Who was Thomas Kuhn? Thomas Kuhn, an American physicist turned philosopher of science, published The Structure of Scientific Revolutions in the 1962. The book challenged the widely accepted belief that science progresses through a steady accumulation of knowledge. Kuhn's groundbreaking argument was that science actually advances through periodic, revolutionary changes in thinking, what he called paradigm shifts. So, what is the concept of a paradigm? In Kuhn's framework, a paradigm refers to the entire worldview that a scientific community holds at any given time. It includes the theories, laws, methods, and standards that guide research. For example, during the time of Isaac Newton, the Newtonian model of physics was a paradigm. Scientists working within this paradigm engage in what Kuhn calls normal science. So, what is the normal science? Normal science is the everyday work that scientists do within an established paradigm. It's a process of puzzle solving. Scientists apply the existing rules to explain the world, confident that the paradigm holds the answers. During this phase, anomalies, observations that do not fit the paradigm, are usually dismissed or explained away. It's business as usual, and scientific discoveries are incremental. You might ask, but what happens when too many anomalies accumulate? Over time, these unexplained discrepancies cannot be ignored anymore, leading to what Kuhn calls a crisis in the scientific community. This crisis happens when the current paradigm is no longer sufficient to explain new data or phenomena. It's at this point that the groundwork for scientific revolution is laid. So, what's a paradigm shift? Well, when a scientific community encounters a crisis, a new theory or model, often radically different from the previous one, emerges to explain both the anomalies and the existing data. This is what Kuhn calls a paradigm shift. One of the most famous examples of a paradigm shift is the move from the geocentric model, which placed Earth at the center of the universe, to the heliocentric model, where the Sun is at the center. This shift fundamentally changed humanity's understanding of the cosmos and led to further breakthroughs in astronomy and physics. Kuhn also introduced the concept of incommensurability. When a paradigm shift occurs, the new paradigm is often so different from the old one that the two cannot be directly compared. They may use different terminology, assumptions, or methodologies, making it nearly impossible for scientists from competing paradigms to communicate or understand each other. In this way, scientific revolutions are not just an evolution of ideas, they are a complete overhaul of how we understand the world. So, what are the phases of scientific development? According to Kuhn, the development of science can be broken into distinct phases. There is normal science, where most scientific work occurs within an accepted paradigm. Then we have a crisis that is triggered by accumulating anomalies that the paradigm cannot explain. Then we have a revolution, the paradigm shift, where a new theory replaces the old one. Lastly, we have a post-revolution. The new paradigm becomes a framework for normal science again until the cycle repeats. This cyclic nature of science, with long periods of stability interrupted by sudden revolutions, is one of Kuhn's most influential ideas. So, what's the impact of Kuhn's work on the philosophy of science? His work sparked heated debates. Before this book, science was generally viewed as a linear, cumulative process where knowledge builds steadily over time. Kuhn shattered that view, showing that science is not always a steady march towards progress. It's full of upheavals and at times chaotic. His ideas have both been praised and critiqued. Supporters argue that Kuhn's model is a more realistic depiction of how science works in practice. Critics have pointed out that Kuhn's focus on revolutions may overemphasize the role of drastic shifts in science. While paradigm shifts are indeed important, many scientists argue that much of scientific progress is incremental and cumulative, even within paradigms. Some also claim that Kuhn's idea of incommensurability exaggerates the communication gap between different paradigms. Despite these critiques, Kuhn's work has left an undeniable mark on how we think about science. So let's conclude and leave some final thoughts. His groundbreaking ideas challenge the notions of science as a straightforward linear process. Instead, he shows that science is a series of revolutions that completely transform how we see the world. From normal science to crisis and revolution, Kuhn's framework helps us understand the ebb and flow of scientific progress. Whether you're a scientist, a student, or just someone interested in how knowledge evolves, Kuhn's work offers invaluable insight into the nature of discovery. So, if you've enjoyed this breakdown of Kuhn's revolutionary ideas, don't forget to like, subscribe, and comment below on which scientific revolution fascinates you the most. Thanks for watching.